Thank you very much. Thanks for the opportunity to speak here today. Thanks to the NSF and the conference organizers. I have a daunting task of being between us and the Coliseum and dinner, so I will try my best to tell the story in a pithy manner and try not to have people fall asleep at this late afternoon time. So I'm a neurologist. Right, so I'm a neurologist at Mass General, and I think one of the unique things about this conference is that it brings together occupational physical therapists, MDs, as well as scientists and clinicians. And it's a really unique opportunity to all think together. As a neurologist, I take care of stroke patients in the acute hospital. I see consults in inpatient rehab. I see patients at home, as well as in the outpatient clinic. And I think that we really have to think critically about outcome measures after stroke. So I'm not going to convince people of the problem. I think a lot of people have spoken about this today. Stroke is a big problem. It affects 800,000 people per year in the US. I'll focus a little bit today on upper extremity motor deficits, which are a major source of disability after stroke. And really, in contrast to acute stroke, treatments for stroke rehabilitation have remained limited over the last many years. And so what we think a lot about in my lab is how can clinical research inform everything we do here? We think a lot about this problem because I think there's not enough of a dialogue between the researchers and clinicians. And so we think about, what can we do on the clinical research side to help everything you guys all do? So I'll start the story with acute stroke. So on the top here is an image of a blocked artery in the middle cerebral artery. On the right, you see a big clot in the middle cerebral artery. The bottom, a neurosurgeon has gone in to remove the clot. And these are the resulting strokes. So on the top, you'll see a big stroke that affects the cortical territory, as well as the subcortical territory. On the bottom, you'll see a smaller stroke. And acute stroke really thinks about outcome measures at the level of disability, right? So the modified Rankin scale, which is a scale that measures anything from being dead at 6 to no symptoms at 0, is a scale of global disability. And since the advent of TPA in the mid-1990s to endovascular therapy, even during my training in the 2015-2017 range, the field of acute stroke has really transformed. But so in acute stroke, we think about a biology. There's a biology of cell death, et cetera. In stroke rehabilitation, there's a very different biology. I think we have to match the outcome measures that we're using in stroke rehabilitation to fit the biology. And that's one of the key points I'll talk about today. So this is a paper that we published a few years ago in neurology. Kim Erler is an assistant professor at the MGH-IHP. So she became really interested in thinking about how outcome measures that we use in stroke rehabilitation fit onto the modified Rankin scale. So the top row is the modified Rankin scale, with 0 being no symptoms and 5 being bedbound. This is a cross-sectional sample of about 80 patients with stroke at 90 days after stroke. And the top row beneath that is the upper extremity Fugl-Meyer scale. So as you can see, on the far right is poor outcome. That would be like a 0 on the Fugl-Meyer. On the far left is good outcome. And as you can see here, so for patients who have a modified Rankin scale of 2 or 3, they can range on the Fugl-Meyer from literally near plegic of a Fugl-Meyer scale of around 6 to nearly perfect of a Fugl-Meyer scale of almost 66. And so you can imagine that if you were to use the modified Rankin scale as an outcome measure in stroke rehabilitation, you wouldn't capture any of the variability that is captured by the Fugl-Meyer. The other point is that I'll make is that outcome is not the same as recovery. So the plot on the left here is if you look at the x-axis, that is a plot of the baseline Fugl-Meyer. The y-axis is a plot of the 90-day Fugl-Meyer. And the top left quadrant are patients who have gone from nearly plegic to nearly perfect. But on the modified Rankin scale, if you look at the dark colors on the top left, those patients are still classified as poor outcome. And so if we're using the modified Rankin scale to classify the outcomes of patients at 90 days, we're not capturing really anything about the arm, and we're not capturing recovery in stroke. Okay, a lot of arm and hand motor clinical trials after stroke have really focused on the Fugl-Meyer. And as you guys know, the Fugl-Meyer is a 0 to 66 point scale. And our lab showed in 2019, and I think Supli Liu spoke about this a little bit this morning, that a lot of the work in stroke rehabilitation has really focused on the corticospinal tract. And essentially people have shown that how much injury you have to the corticospinal tract, which is shown here in green, can map onto how you recover after stroke on the Fugl-Meyer scale. So in the middle panel here, what I've shown is a patient with a large stroke in red with very little overlap on the corticospinal tract, and you see that they recover very well. On the bottom in panel B, you'll see that there's a patient who has a very small stroke, who has overlapped the corticospinal tract a lot and hardly has any recovery in the first 90 days after stroke. But it's much more complicated than that, I would say. So in this project, we thought about two really simple outcome measures. We had patients squeeze a dynamometer, which is a really simple task at the bedside. And we had patients move a set of blocks, essentially from one side to another. And that takes a minute. And our hypothesis was that for stroke patients, especially acutely after stroke in the first week, when there's all sorts of other stuff going on, they're inattentive, et cetera, that it would be much harder for them to perform the box and blocks task. So what you'll see here is, so for both the affected arm on the left and the unaffected arm on the right, the box and blocks is in red and the grip strength is in black. What you'll basically see is that in the first 90 days after stroke, the performance on the box and blocks task is always worse than the performance on the grip strength task, right? And that's true for both the affected arm and the unaffected arm. If we map the performance on those tasks to where the injury was in the brain, we'll see on the bottom row that the grip strength really maps onto motor parts of the brain. You'll see the motor cortex highlighted in the bottom rows, as well as the corticospinal tract. But so for the box and blocks task, which is really a cognitive task, as we're showing here, you get many more parts of the brain that light up, including the insula, as well as other places. And so our major point here is that even two very simple tasks that are used really at the bedside all the time in stroke have a unique anatomy behind them. Okay, the last thing I'll say in the last couple minutes is that in stroke, we've started to think a lot about essentially different outcome measures. So in yellow here, you'll see impairment-based outcome measures, in green, activity-based outcome measures, and in blue, participation-based outcome measures. And so Julie in my lab has thought a lot about these different classes of outcome measures. And another way to categorize this is that there are outcome measures that patients can report, meaning they say how they're doing. And there are outcome measures that they perform, like the Fugl-Meyer and box and blocks. And you'll see two patients here, one on the top who is performing very poorly on the Fugl-Meyer, et cetera, but who is reporting that their health is very good over the first year of stroke. While on the bottom, there's a patient who has a large left MCA stroke, who is performing actually quite well on the performance-based measures, but is performing very poorly on how they're rating their self-reported health. If you do a principal components analysis of that, you'll see that the PROMs and the performance-based outcome measures really separate completely orthogonally. So we took a cohort of 54 patients and we did this at 3 time points after stroke. And then we ran a few models and we showed that essentially, if you look at things like education and income adequacy, that really predicts how people report their health, but doesn't have much to do with how they're performing. And finally, if we look at where that maps onto places in the brain, there's a unique anatomy, again, to where we think about patient reporting health, and that really maps on to places in the parietal lobe, which are known for self-reflection, et cetera, while the performance-based outcome measures will map onto places like the corticospinal tract in blue. Okay. I think this might have frozen. Can you go forward one? Okay. Okay, skip forward. Okay, so a lot of the data I talked about in those 3 studies I talked about today came from a natural history study of stroke that we've been running the last 5 years in Boston. And I'd say that I think one of the key places that we can that we need to think forward as a community is how to gather data at the point of care. I think for everything that people have talked about today, and for our own work in Boston, really, we need to be able to collect data in large samples at the point of care to move the field forward. And the last thing I'll say is that in future work in our lab, we've been going back and looking at videos of our participants as they perform upper extremity movements. And so this is a patient who's doing the Fuglemeier. And you'll see that as he performed 2 movements of the Fuglemeier, this is like essentially the proximal subscales. So you'll see that the movement is not quite the same every time, right? It's slightly different. And so we've been thinking about how to, in my lab, about how to capture that variability. And so one of the ways to do that is with an in-motion arm. And so we've been having acute stroke patients move an in-motion arm while on the acute stroke ward. So we did that with 23 patients in the first week after stroke. And just very briefly, I just want to say that if you do that and you look at the box plots of their smoothness, which is shown on the top right, you'll see that there's a tremendous amount of variability in smoothness in acute stroke. And that's really interesting. And I think that we have to think about modeling the variability to acute stroke behavior. And I think that's a unique opportunity. All right, so just to wrap up, I know I've gone over time and I've cut into dinner, but I think we've learned some lessons over the last few years from our work in the lab. And in terms of answering the questions, which I know we've gotten far away from in the afternoon, I've thought a lot about the questions, which I think are great. But I think that, in conclusion, we have to think about learning healthcare systems in stroke and gathering data at scale. Outcome measures after stroke have a specific neuroanatomic basis. And I think that's really one place that we can think together hard about is really about outcome measures after stroke. Lastly, this is my last slide, I promise. We wrote an editorial in Neuron this past summer with some collaborators at UCSF, and I think this is a really complicated motor control problem. And I'm really inspired by everybody here because I think if we work together, we can solve it. But I think this is a very complicated problem, and I think it takes a big community like this to solve it together. Okay, this is sources of our funding. This is my lab and my 2 kids who have grown up with it in the last couple of years. And these are my collaborators and all the people that have done this work. Thank you.
Okay, maybe I can start with one.
Excellent talk. So if I follow your results, what you showed was that when people have these poor patient-reported outcomes, those were associated with function, some measure of function in more frontal regions. Is that correct?
So the first thing we showed is that patient-reported health and performance-rated health are basically orthogonal. Second, and then they map to different areas of the brain. And patient-reported health seems to map to more parietal regions, which are known to be important for self-reflection, et cetera.
Okay, so my question is that in the clinical world, there's a huge push, or even sort of the current reality is that people are often evaluating patient-reported outcomes as a measure of the efficacy of rehab. So what does your work say to those who view that as the
we're writing up the paper now, and we're going to put that in the discussion. But I think there's certainly value to patient-reported outcomes, but I don't think they should be a replacement for performance-based outcomes because they measure different things. And so that's one of the big points, is that we just should think neuroscientifically about outcome measures. And I think there's a lack of that in clinical stroke.
Point of clarification. I think you said recovery and outcome measures, and then you switch language to patient-based and performance-based. So which is which? So is patient-based recovery?
Yeah, so when I think about recovery, I'm talking about a delta change between 2 outcome measures. In the study I showed, though, we were just looking at outcome measures, meaning we were looking at outcome measures in cross-section at 3 points in time.
But you call, so it's performance-based. Is that outcome measures? Delta?
Outcome measures, exactly.
Yeah, delta and outcome, whereas patient-based is
also outcome measures.
But you said before there was recovery versus outcomes.
Yeah, that was a separate study in which basically, so I'm sorry, that was probably confusing, but right, that was a separate study in which we were basically making the point that outcome measures and recovery are different things. Meaning when you're looking at recovery, you need to measure 2 outcomes at 2 different points in time and study the delta. while outcome, you measure something cross-sectionally and you study that. And acute stroke has really looked at outcomes because you're saving half the brain. So outcome measures will inevitably improve.
We have one.
And just to piggyback on that, I may have misfollowed it, but it looked like at first when you were talking about like at the ICF, you were mostly grouping the participation as the patient reported outcomes. So like, you know, I mean, it seems like there's a bit of a conflating too between different constructs within the ICF.
Yeah,
and the
so
actual methodology.
yeah,
for it.
totally agreed. So the participation, so the participation-based outcome measures that we collected in this study were mostly patient report. And so that is true, meaning like there are dimensions of the ICF and there are patient-reported outcomes, and those are different constructs. But it just happened to be that in this study, we collected patient-reported outcomes that were mostly participation-based.
It's possible there could have actually been just a dissociation on the levels of the ICF they were actually performing on.
It could have been. I mean, it could have been, but I think that, yeah, I mean, I guess it gets to the heart of the question of the constructs of the ICF, but yes.